Hi there. We talked today in class about using logarithmic differentiation to find dy dx of a given function. And so in this case we have y equals the square root of x squared minus 1 over x squared plus 1. Using logarithmic differentiation we follow 5 steps. They're all outlined in your notes uploaded on my website. The first step is we're going to take the natural log of both sides of the equation. So we end up with the natural log of y is equal to the natural log of the square root of x squared minus 1 over x squared plus 1. The reason we do that is because now that we've taken that natural log of the right side in particular, we're going to be able to expand that in order to simplify terms a little bit before we take our derivative. And so we have natural log of y equals, and we can expand this. We know the square root can be split between the numerator and denominator. And so we end up with 1/2 natural log of x squared minus 1 minus 1/2 natural log of x squared plus 1. And again, this just gives us a little bit more of a simple derivative to take, because now we can look at each natural log term individually. And so we have the derivative. This is step 3, take the derivative. Derivative of the natural log of y is our u, makes u prime 1, so we're at 1 over y, and then we need to acknowledge that this isn't an x, right? We're taking the derivative with respect to x, and so we either write dy dx or y prime. Over here, our u is x squared minus 1, which would make our u prime 2x. So we have 1/2 times u prime over u, 2x over x squared minus 1, minus that 1/2, and then again u is x squared plus 1, u prime is 2x, so u prime over u, 2x over x squared plus 1. And before we do anything more to isolate the y prime, I'm going to clean up this right side of the equation. So I'm going to leave this left side as y prime over y. I notice here that the 1/2 and the 2 will simplify, so we have x over x squared minus 1, and same here, 1/2 and 2, so minus x over x squared plus 1. And then I'm going to look to combine these two terms. To do that I need a common denominator, so I'm going to multiply this term by x squared minus 1, this denominator. And this first term I'm going to multiply by this denominator, x squared plus 1. That way we'll have a common denominator and can combine the two. So we have y prime over y is equal to, I'm going to go ahead and distribute that x. We have x cubed plus x minus, distribute that x cubed minus x, all over x squared minus 1 times the quantity of x squared plus 1. Again, I can still clean this problem up a little bit. So I'm going to leave this as y prime over y equal to, distribute that negative in, we have x cubed plus x minus x cubed plus x, all over the quantity of x squared minus 1 times the quantity of x squared plus 1. And clean it up one step further, we have y prime over y is equal to x cubed minus x cubed. They cancel each other out. So we're left with x plus x, or 2x, all over the quantity of x squared minus 1 times the quantity of x squared plus 1. Okay, so I'm not quite done. Step 4 is to isolate that dy dx, or that y prime. And I notice here that there's a divided by y, so I'm going to times by y to both sides. Okay, so I'm left with y prime equals 2x over x squared minus 1 times the quantity of x squared plus 1, all times y. And then that 5th step is to substitute in our values in for y. We were given up at the beginning, our initial equation was y equals the square root of x squared minus 1 over x squared plus 1. And so that square root is what I'm going to put in for y, is what I'm going to substitute in. And then I'm going to simplify if possible. So I have y prime equals 2x over quantity of x squared minus 1 times the quantity of x squared plus 1 times, and my y was that square root x squared minus 1 x squared plus 1. And I went ahead and split that square root. There, split that square root between the two, the numerator and the denominator. And so now I'm going to be looking to see, can I simplify anything one step further? And I do notice there's a couple of steps I can take. The first is here in the denominator I have 1 whole x squared minus 1. There's an exponent of 1 here that we just don't write. And up here in the numerator we have an x squared minus 1 to the 1/2. And so they can simplify. Okay, and when we are dividing bases, we subtract their exponents. So we have 1/2 minus that 1. I'm going to leave the 2x for now. And so 1 minus 1/2 is going to be 1/2. So this square root cancels out half of this whole. And right here we have an x squared plus 1 and an x squared plus 1. This first has an exponent of 1, and this second has an exponent of 1/2. And when we multiply bases, we add their exponents. And so that base, that x squared plus 1, is going to be raised to the 1 plus 1/2, which is 3/2. Now that I've simplified all that I can, that's my answer.